Okay, this is Algebra 2, Year 2, Section 11.2, homework. And this was all on probability. So number 1 says a basketball player attempted 24 shots and made 13. Find the experimental probability that the player will make the next shot she attempts. So this was our probability. So probability, make shot. That equals how many she's made, which is 13, over her total number of shots, which is 24. So it's 13 over 24. We can get a decimal answer for that. If we plug it into our calculator, and we get 0.54. And if you make that a percent, it's 54%. And remember, to get the percent, you're multiplying this by 100, or you're just moving the decimal place over 2 spots. Number 2, a baseball player attempted to steal a base 70 times and was successful 47 times. Find the experimental probability that the player will be successful on his next attempt to steal a base. So again, probability, steal base. He was successful 47 times, and he tried 70 times. So we get 47 over 70. And when you plug that into your calculator, you'll get a decimal that is 0.67, which translates to 67%. For the next section, this is our theoretical probability. So we have a group of 5 cards that are numbered 1 through 5, and you're choosing one card at random. And we need to find the theoretical probability for each of these next problems. So our entire set are cards numbered 1 through 5. Number 3 is asking for the probability that the card is a 2. So how many 2s do we have in our entire set?
1.
Just 1. So we only have 1 2. So probability that it's a 2 is 1 over our entire set, which is 5. So it's 1/5. Number 4, the probability that it's an even number. What are our even numbers in our set? In our original set?
2 and 4.
Just 2 and 4. So our probability that it's an even number is 2 over our entire set. So it's 2/5. Number 5 is that it's a prime number. So what are our prime numbers in our original set?
1,
1
3, and 5.
and 2, because we talked that 2 is just 2 times 1, so it's also a prime number. And then 3 and 5. So we have 4 prime numbers out of our 5, so it's 4/5. Now number 6 says the probability that it's less than 5. So what are our choices for less than 5? 1, 2, 3, and 4 are all less than 5. So again, our probability that it's less than 5 is 4 over the entire set, which is 5. The next set is also theoretical probability. We're given a bucket that contains 15 blue pens, 35 black pens, and 40 red pens. We're picking one pen out at random, and we need to find the theoretical probability. So what I would do first is find our total number of pens. So we have 15 plus the 35 plus the 40. So in all, we have 90 pens total. So number 7 says the probability that it's a black pen. So how many black pens did we have?
35.
We had 35. So we have 35 black pens out of the total, which is 90. And then we can reduce this fraction to 7/18. And again, you can leave these as fractions, as decimals. I'll accept both answers. So number 8, the probability that it's a blue pen or a red pen. So how many blue pens did we have? We had 15. And then how many red pens did we have? 40. So we're going to pick either a blue pen or a red pen. So we've got both of those on top, and that's out of our 90. So this equals 55 over 90. And again, we can reduce this fraction to 11 over 18. Number 9, we're finding the probability that the pen is not a blue pen. So that means it could be a black pen or a red pen. So just like in the problem above, it could be black, so it could be 35. We have 35 choices for the black one, plus 40 for the red, and that's over 90. So that equals 75 over 90. Which again can be reduced and equals 5 over 6. And number 10. The probability that it's a black pen or not a red pen. So it could be a black pen or a blue pen. So it could be a blue pen, which we have 15, or it could be a black pen, which we have 35, and then it's still over our 90. So we get 50 over 90, which reduces to 5 over 9. And this section now is about the geometrical, or the geometric probability. And we're given that a rectangular yard shown below has a circular pool and a triangular garden. A ball from an adjacent golf course lands at a random point within the yard. And then we need to find these theoretical probabilities or geometric probabilities. So first we need to remember our area formulas. So the area formula for a circle is pi r squared. And the area formula for a triangle is 1/2 base times height. So now, before we even answer any of the questions, I would find the areas of each section in our yard. So first we'll find the total area. And the total area is just this rectangle that we're given. And we're told that it's 50 feet by 100 feet. So to find the area of a rectangle, it's length times width. So we have 50 times 100. So that equals 5,000. And then we'll find the area of our pool. Which is our circle here. And our area formula says pi r squared. Our r is 12 feet. So it's pi times 12 squared. So we can just leave that as 144 pi. And then we need to find the area of our garden, which is this triangle in the corner. So area of the garden. To find the area of our triangle, we use 1/2 base times height. Our base is 8 feet, and our height is 6 feet. So it's going to be 1/2 times 8 times 6. And when you plug that into your calculator, you end up getting 24. So now we're going to use these numbers to find our probabilities in this problem. So in 11, it says that the ball lands in the pool. So probability of it being in the pool. So we're going to take the area of the pool, which was our 144 pi, and that's going to be over the entire area of the yard, which was the 5,000.
Discussion.
So when you plug that into your calculator, you get 0.09, or approximately 9%. For number 12, the ball lands in the garden. So the probability that it lands in the garden is the area of the garden was 24, and then over the entire area of the yard again, which was 5,000. So you get approximately 0.005. Number 13, the ball lands in the garden or the pool. So the pool or garden. So we have the area of the pool, which is 144 pi, plus the area of the garden, which was 24. And then we're still dividing by 5,000. And you'll get approximately 0.095, or approximately 9.5%. And number 14, the ball does not land in the pool. So probability not in So that means that we're going to take our entire area and subtract the area of the pool, and then divide by our entire area. Because this is saying that you have all the rest of the area that isn't the pool, is what we're doing on the top here. And you get approximately 0.91, or 91%. Going on to the back. Number 15, we're finding the probability that a letter chosen at random from the letters of the word permutation is a vowel. So your vowels are A, E, I, O, and U. So we have 1, 2, 3, 4, 5. The probability of vowel. We have 5 vowels, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters in all. So it's 5 over 11. Number 16, a letter chosen at random from the letters of the word mistletoe is a consonant. So consonants are all of your other letters. So probability of consonant, we've got 1, 2, 3, 4. We've got M, S, T, L, and another T. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in all.
So all you do is pretty much count it.
Oops. You have 5 consonants, sorry. What was your question?
So pretty much you just count it.
So you're just counting how many consonants or how many vowels you have in those two. So number 17. A spinner is divided into 12 equal regions numbered 1 through 12. Find the probability of each event for one spin. So again, your entire set is 1 through 12. So for 17, we're looking for the probability that you get a 2. So there's only 1 2 in our set. So probability that you get a 2 is 1 over your entire set, which is 12. 18 asks the probability of getting a 10. So again, there's only 1 10 in the set, so it's 1 out of 12 again. 19, that you get an even number. So our even numbers are 2, 4, 6, 8, 10, and 12. So probability of even, we've got 1, 2, 3, 4, 5, 6. So we've got 6 out of our entire set was 12, and we can reduce this to 1/2. So half of our numbers are even. So number 20, it's asking for odd. So if it's not even, it's odd. So we've got 1, 3, 5, 7, 9, and 11. So probability of odd. Again, we've got 6 over 12, which equals 1/2. So half of our numbers are even, half of our numbers are odd. Makes sense. Number 21, probability that you have a prime number. So again, our prime numbers are 1, 2, 3, 5, 7, and 11. So we have 6 prime numbers, so probability of prime is 6 over 12, which again equals 1/2. Number 22, probability that you get a number greater than 3. So all the numbers greater than 3 are 4, 5, 6, 7, 8, 9, 10, 11, and 12. So probability greater than 3, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's out of our original 12. And we can reduce that to 3 out of 4. Number 23, a number less than 8. So all of our numbers less than 8, 1, 2, 3, 4, 5, 6, and 7. So probability less than 8, we have 1, 2, 3, 4, 5, 6, 7. And that's out of our original 12. Number 24, a factor of 8. So our factors of 8 are 1, 2, 4, and 8. So probability factor of 8 equals 4 over the original 12, which reduces to 1/3. Number 25, a multiple of 3. So our multiples of 3. Remember, a multiple is anything that can be divided by 3 and you get a whole number out. So we have 3, 6, 9, and 12. So probability that it's a multiple of 3 is again 4 out of 12, which equals 1/3. And number 26, our final problem. What is the probability that a randomly thrown dart that hits the square board will land in the circular region? So again, your area for a circle is pi r squared, and your area for the square is x squared. We're going to label our sides of the square x. So we'll find the area of our circle, and that equals pi, and our r is 4, so pi times 4 squared. So this equals 16 pi. And then to find the area of our square, our circle goes from edge to edge
8.
on this square. So if it goes from edge to edge, we're going to double our squares, or our circle's radius, so we get that a side equals 8. And since it's a square, we know that both sides are equal. So both of our x's are 8. So the area for our square is 8 squared, which equals 64. So now to find the probability that it'll land in the circle, we take the area of our circle, which was 16 pi, and we divide by our entire area, which was 64. And we get approximately 0.785, which translates to 78.5%. And we are done.